Bismillahirrahmanirrahim. Allahumma rabbi zidni ilma. Bismillahirrahmanirrahim. Assalamu alaikum. Welcome dear students on the subject of Internet Architecture and Protocols. It's Ghulam Yasin, lecturer in Computer Science, University of Education Lahore, DG Khan campus. So dear students, our today's lecture topic is framing. These are some contents which we will cover inshallah today. To identify what framing is, introduction about bit or byte stuffing, to identify ways of framing, to identify character oriented protocol. So in today's lecture, the main discussion is framing, how frame is created, and how bit or byte stuffing concept is used, and what is a character oriented protocol. Framing. The data link layer needs to pack bits into frames so that each frame is distinguishable from another. Dear students, when data is transmitted from source to destination, we use different words for that data. And if we talk about data link layer, the data is being transferred in the form of frames. So whenever we create local area network, we have to use switch, and switch is deployed on data link layer, and whenever data link layer is used for data transmission, the word frame is used. So basically frame is our data. Next point, our postal system practice a type of framing. So this is an example. Then when our postal system or courier services used to transfer our files, our documents, they put our document or our file in some specific envelope, and after putting our file or our letter in an envelope, the envelope is closed. So over here frame is like that. So frame is a concept to put data in the form of frame. The simple act of inserting a letter into an envelope separates one piece of information from another. The envelope serves as the delimiter. So if I am going to send a specific file or any letter to any person, then my file or my letter will be kept in separate envelope, and if any other person is sending a file or document, the file or document of this person will be kept into separate envelope. So these separate envelope are like frame over here. If there are two users and these two users are sending data from one device to another device, user 1 is source, user 2 is source. So user 1 data will be transmitted separately and user 2 data will be transmitted separately. There is a fixed size frame as well as variable size frame. So it depends on different networks. We use fixed or variable size framing concept, and again frame is data which is being transmitted from source to destination. A frame in a character oriented protocol. A character oriented means data will be transmitted in the form of characters. So over here character oriented protocol is used. So you can see different fields over here. On the left and right side you are going to see flag. So what is basically flag? Flag is used to identify start and stop for data. So when the frame is being started, then this flag will be used, and when the frame will be end means data or frame for next user will be started, then the flag is being used. Header and trailer. A header and trailer. This is again information which is used on data link layer. So header and trailer, this is extra information which is compulsory for data transmission. Next portion is data from upper layer and variable number of characters. So this portion is actually data which is being transmitted from source to destination, and this portion will be converted into frame, and the whole data as well as other relevant information is being transmitted. Byte stuffing. Byte stuffing is the process of adding one extra byte whenever there is a flag or escape character in the next. So dear students, when the frame is being transmitted from source to destination, it contains some fixed size length. If that specific length is not being completed, or you can say that if the total length of that frame is less than the fixed size, then the extra byte or extra bytes will be added or stuffed. So extra bytes will be stuffed to complete the minimum length of that frame. So if the length of that frame is less than the required size, then the extra bytes will be added. This concept is called byte stuffing. Bit stuffing is the process of adding one extra zero whenever 5 consecutive ones follow a zero in the data, so that the receiver does not mistake the pattern 0 1 1 1 1 1 0 for a flag. Dear students, we have discussed about flag in our previous slide. Flag is basically indication to start and stop of a frame, and the pattern of flag is fixed, which is 0 1 1 1 1 1 0. But if any device, switching device which is switch, will receive the pattern of flag, there will be confusion about flag and data. So over here, bit stuffing is concept to add extra 1 0 when there are 5 consecutive 1, because 5 consecutive 1 shows the indication of flag. So differentiate between flag and data or frame, it is necessary to add 1 0, means to add 0 in the end of data or frame. So this is differentiate between flag and data. So bit stuffing is used for differentiation between flag and data. Physical layer and data link layer. So data is transmitted in the form of bits. Physical layer, so the pattern of data transmission is shown over here. Last two layers from bottom side are physical layer and data link layer, and these two layers are very important of OSI reference model, because physical layer is used for actual data transmission. Data is converted into bits, and bits are being converted into signals, and those signals are transmitted on physical layer or on physical medium. So the pattern of data you can see over here is 0 1 0 0 0 0 1 1 1 0 1 0 1 1. So the data is being transmitted in the form of consecutive, you can say, bits, or these are signals which are being transmitted. So signals are not shown over here, but bits are shown, and this is actual data. But on data link layer you can see a frame. So bits are combined to create a frame, and frames are transmitted by data link layer, and after that physical layer will receive those frames, and those frames are being converted into signals, and signals are transmitted. So over here you can see three different frames, and so on. So data on data link layer is being transmitted in the form of frame. Ways of framing. There are three different ways of framing: byte count, character oriented protocol, and bit oriented protocol. Because data must be converted in some form. That form may be bit, that form may be byte, that form may be frame, that form may be packet, or that form may be segment. So these are different ways or different methods for data transmission. So if we transmit our file from sender to receiver, that file is being converted into some form. That forms are called frame, that forms are called packet, that forms are called byte, and so on. So how to create a frame? There are three ways, and we will discuss these three ways of framing in our next slides. Method number 1, byte count. Use a field in a header to specify the number of bytes into a frame. Let's suppose if there are 5, 6, 7, 10 bytes, bytes will be calculated and the number of bytes will be shown in header, and this method is called byte count. So dear students, you can see a byte stream 5, 1, 2, 3, 4, 3, 6, 7, 6, 9, 3, 0, 2, 1. So these are different bytes. And if we create frames of variable size, so you can see frame number 1, frame number 2, and frame number 3. So in frame number 1, there are 5 bytes. In frame number 2, there are 3 bytes, and in frame number 3, there are 6 bytes. So these different bytes are being calculated and the number will be shown in header. So this is a method of byte count. Problem with byte count. There is a problem which is called error. If there is an error while data transmission, then the byte count will be changed. So let's suppose without error in frame number 1, frame number 2, and frame number 3, just we have discussed that there are 5 bytes in frame number 1, there are 3 bytes in frame number 2, and there are 6 bytes in frame number 3. In case of error, you can see the second stream of different frames. With error, frame number 1, frame number 2, frame number 3, and frame number 4. Now there are 4 frames because when there will be an error, this error may be bit error or byte error. So when single bit will be changed or more than one bits will be changed, so this will be an error and the count will totally change. So this method is not appropriate because byte count method creates a problem when there is an error while data transmitting from source to destination. The response using flag byte. So the problem can be resolved with the help of again flag. We have discussed about flag in our previous slide as well, but what is flag? Flag is indication to start and stop of a frame. So you can see over here frame number 1, frame number 2, and frame number 3. Instead of byte count, there is another method to specify flag in the start of frame number 1 and in the end of frame number 1, as well as frame number 2 contains flag in the start as well as end, and frame number 3 also contains a flag in the start of transmission and at the end of transmission. So flag is commonly used mechanism to indicate the start and stop of data so that data will be transmitted in efficient manner. Method number 2, character oriented protocol, uses a flag byte that is used as both the starting and ending delimiter. Flag byte uses the character in ASCII form, and ASCII are American Standard Code for Information Interchange. So dear students, over here you can see a stream of frame or byte. So this is frame 1, frame 2 and frame 3, and flags are being used at start and end of transmission. So there is frame 1 which contains 4 bytes and flag is being used over here. Next, frame 2, there are 2 bytes and flags are being used at start as well as at end, and frame 3 contains 3 bytes and flag is being used at start and end of transmission. So this is character oriented protocol method. There is a problem with character oriented protocol as well. Flag byte occurs in the data. Original byte, let's suppose A and B, and flag as a data. So there are 2 bytes AB and there is a flag which is being used for start as well as end of transmission. So problem is this: if the original byte, which is A, is same as the flag, then there will be a problem for distinguishing data as well as flag. So after stuffing escape character or a byte stuffing, there will be a distinguishing between data as well as flag. So in this way, flag and data can be differentiated. So this problem can be resolved by byte stuffing. And what is problem? If original byte or frame is same as the flag, then byte stuffing mechanism is used for differentiating data and flag. Byte stuffing, the technique of inserting a special byte just before each accidental flag byte in the data, is called byte stuffing, and we have discussed in detail that byte stuffing mechanism is used when the frame and the flag is same. So differentiating between frame and flag, we will insert special type escape, and this is called byte stuffing. Problem with character oriented protocol, although we have discussed that if original byte and flag is same, then we will add a special byte which is escape or data. But over here you can see that there are 2 original bytes A and B, and we have inserted escape as data. But after stuffing, you can see escape and escape as data, because now escape as data is same as the B byte or A byte. So we have to change this escape as data again. So we will insert another escape byte, and in this way the differentiate is done between A and B. So differentiation will be done with the help of adding another escape as data over here. Again, problem with character oriented protocol, escape and flag occurs in the data. In this scenario you can see 2 bytes which are original bytes A and B, and there is a flag as data which is same as B, and we have inserted escape as data. But after inserting escape as data, now escape and flag as data, these are same. Now we have to resolve this issue. So after stuffing, in next scenario you can see we have inserted a flag, we have inserted escape, and we have inserted escape as data. So one escape byte is inserted with A, one escape byte is inserted with B as well as flag, and escape as data is being inserted previously. So in this way we will control the problem of the same bytes which are being occurring by data as well as flag and as well as escape character. This is our last slide regarding character oriented protocol, and over here there is another scenario. There are two original bytes A and B, and we have inserted escape as data on both sides, means with A as well as with B. But the problem is this: while inserting escape as data with A as well as with B frame, these are again same, means the data of A as well as escape as data is same, the data of B as well as escape as data is same. Now we have to insert another escape so that there may be differentiation between data as well as escape character. So we will insert again escape, or we will insert again a byte for differentiation. So after stuffing, you can see another scenario. There are two original bytes A and B, and escape as data, escape as data, this is previously inserted. Now we have insert another escape which is a single special byte for differentiation. So in this way we can differentiate among data as well as flag and as well as escape byte. Method number 3, bit oriented protocol. This is very simple. Over here uses a special 8-bit pattern flag as the delimiter to define the beginning of the frame. So over here just we will add a special flag which we have studied in our previous slides as well. So you can see flag, data, flag. So data is being transmitted in the form of continuous bit stream, and this data is being differentiated by flag, which is indication to start of data, and after that another flag which is indication to stop of the data. So in bit oriented protocol, simple flag of 8 bits is used, and in this flag there is a predefined pattern of bit stream. Bit stuffing, there is a single rule of bit stuffing. When sending 5 consecutive 1 bits, a 0 bit is stuffed. So if there is a data which is in consecutive form and there are 5 consecutive ones, after that 1 bit 0 will be inserted. This is a bit stuffing concept. So dear students, in this way we have completed the concept of framing, how framing is being created, how framing is being done, what are different ways to create frame as well, and what is basically character oriented protocol. So in this way we have completed the concept of framing. So dear students, thank you very much for your concentration, for your learning, for your passion. I hope best of luck for all of you always.